Hello all. So in last class, we have seen the unigrams or just simple bag of words. Why I call it unigram? Because we just used one word to create a vector. But we have seen that there will be 175,000 words, right? Or 1,000 dimension. And most of them will be zero. And that's why that's sklearn also call it a sparse matrix because it's not good to save a lot of zeros, right? It's more memory consuming. You can understand in that way, and that's why it's internally stored like a dictionary. Okay, but that's the memory management topic. But let's focus on the next topic, which is the bigrams. So we will see both unigrams and bigrams in naive base. We'll train the model naive base. But before doing that, what if we can use? So we have just simply used one word, right, to create a vector. But what if we can use just a pair of words like this? For example, if I consider a window of two words and then create a vector. So two consecutive words. So firstly, I will consider I loved, then I will consider loved the, then I will consider the suspense, and so on. What if we can do something like this and then create a vector? And then if we create a vector, then it will be a bigram. Now, obviously, as compared to unigrams, okay, bigrams will be a lot more. So, I mean the vector size. Okay, so uh, at that time we are with the unigram we had I think 175,000 around dimension. Here it will be even more than that. Then similarly we can use trigram, and in general we can use n-gram in general. So it's like using n consecutive words. So here it will be this entire cell will be I loved, let's say. Okay. Then this cell will be loved the, and so on. And then we will fill the number of occurrence or the frequency counts, and then we will create a vector. So this is called bigram. And why is it is being used? Because consider this review R1 and R2. If we remove the stop words, not, right, and I and so on, the and so on, then this two review will be exactly same, right? If we just use unigram, right? And the one solution to solve such a problem is bigram. So here we will not first thing, most important thing is that we will not remove stop words. Okay, especially we will not remove not, because this entirely change the meaning, because these two are totally opposite. But if we remove stop words like not, then these two reviews are the same, which is not true, right? Because then the vector for both this will be the same, and which is not true, right? And one solution can be bigram, trigram, or n-gram in general for such. We will see other solutions as well, but this is one of the solutions. So let's see one good example, just one lame example, and then we will go through this thing, okay, which is the actual IMDB reviews. So here I have written that removing stop words like not should be avoided. We have to remove rest, but not should not be removed. Okay. So what we can do, one thing we can do is in the list of stop words that we had here, right? Here we have not. What we can do, we can just remove this. Okay. So just what we have to write, we have to write just one this additional line, which I just wrote before recording this. So just write this thing and you will be fine. So just remove the not from this stop word and then execute rest of the cells. So let's see one simple example and also see some other parameters. So here we didn't give any number of parameters, right? Here just simply we have given count vectorizer and everything was by default. Okay, so if you will see here the count vectorizer, the default, all the default where parameters values will be taken, right? You can see whatever we have seen n-gram range, so it will be 1 1, so it will be unigram. What we do 1 1, it was default, right? We didn't explicitly write so anything, it will be 1 1, it will be unigram. Now 1 2, what will be 1 2? Okay, 1 2 will be unigrams and bigrams combined, so this vector will be even more bigger because we are considering single words as well as pair of words. 2 2 means only bigrams, so similarly 3 3 will be meaning only trigrams. But if we write 1 comma 3, then it will be unigram, bigram, and trigram, and so on. Okay, so this will be even more bigger dimension or more bigger vector, right? Like a lot bigger than 175k that we had just for unigram. Okay, so let's see very simple text. I love programming in Python, and second is Python is great for data science. Here we are not classifying it or anything. It's just we have to see how to convert these words into a vector using bigram. So firstly, since we are using bigram, it's 2 2. Okay, so we are not taking care of both. It's we are taking care of just one unigram. Sorry, bigrams only, not 1 comma 2, which will be unigram as well as bigram. Now what we are doing, we are just saying simple vectorizer dot fit transform. So we are firstly instantiating this class with the argument 2 2, and then we are just calling this fit transform on this data simple text, and then we are just calling out the names. So firstly what we will get is all the names of the bigrams. So you can see bigrams, print bigrams. We are just converting into the array. So you can see all these are bigrams, data science, for data, grade for in Python is grade, okay, and so on. You will notice that I is gone somehow. I'll tell you what happened. Okay, but first let's consider that it ignored I. So I was ignored. Okay, why it was ignored? Because of this parameter min underscore df and max underscore df. So let's try to see what does it mean and why it is being ignored. So here you will see that what this min df and max df means. So df stands for document frequency. Now you might ask, what is this document? So in natural language processing terms, let me write this, that all the reviews that are being given are called corpus. Entirely, like in total, all the reviews or all the text that we have in a data set, it's collectively called as corpus. And each of this review is called document. This will be document 1, this will be document 2, and so on. Okay. So now what this means by document frequency. So here it's simply written that when building the vocabulary, ignore the terms that have a document frequency slightly lower than the given threshold. So on the minimum side. So what we will do, that will ignore all the terms or all the words specifically which occurs less than this, whatever we specify here. So its default is 1. So if you apply float, so it's let me just write it in a paper so it will be better for you. So what does this mean? Let me write it here. So let me just copy paste. Okay. I hope it's visible. Here it's better. So when, this is when, and let me erase the rest of the stuff. Okay, then erase. Then let me paste it again. So when max underscore df is set as float between 0 and 1, it represents the proportion of the documents in which a term can appear. For example, this will make it clear that if max underscore df is 0.85, let's say, then vectorizer will ignore the terms that appear in more than 85% of the document. So it will check all the reviews, that is all R1, R2, R3, all the movie reviews that we have. And if any word occurs in more than 85% of all the reviews, it will be ignored. That is the work of max underscore df. Now you might guess what will be the min. Min will be what? Min will be the other way around. That it will be on the lower side. That if word is really less frequent. Okay. So what will be the example of this max underscore df? When we have to, it's specifically written that there are some stop words like the occurs a lot in almost all reviews, it will occur, right? So if we write 0.85, because it occurs in almost all reviews, it occurs in 100%, right? So 100% is greater, right, than 0.85%. Then the will be ignored while building the entire vocabulary. Okay, but what if we apply it as an integer? That also is a valid question. So when we set it as an integer, let me also copy paste that thing so that it's useful for you for your notes. And so when it's set as an integer, what we will do, it specifies the maximum number of documents in which a term can appear. For example, if we like put it as a 10, then any term that appears in more than 10 documents will be ignored. Okay, so if we apply any term which has, like for example, is appearing in more than 10 documents, it will be ignored. Okay, by default is 1. So that's why our I was ignored here. If you notice that while creating the bigram, I was ignored because by default this is, we didn't like apply anything, right? No parameters. So by default it will take all the default parameters. So since this was the maximum and minimum threshold, and that's why I was ignored somehow. So if you will see now here that what we are doing, let's try to construct this now. Let me show you that how this word to vec, or this I love programming in Python, is converted into a vector. So you can see first will correspond to data science. Now you, because these are first, second, third, fourth, fifth, sixth, 7 and 8. Okay, so it will be 8 dimension vector. You can see 4 and 4, 8. Now first will be data science. Does this has a data science? First, no. The first text doesn't have, so it will be 0. Second will be for data. No, it's absent. Third will be create for. No, it's absent. Fourth will be in Python. Yes, in Python is there. So what we will do? We will put 1. Okay. Similarly, we'll move ahead. Is great is not there, so 0. Then love programming, it's there, so we will put 1. Then next, what is programming in? Programming in is there, so we will put 1. And last is Python is. Python is no. In Python is there, but Python is not there, so it will be 0. Similarly, you can construct for this, right? So this is how the n-gram, or you can say bigram, works. Okay, and let's see now the rest of the things. So especially for our purpose now, this was just an example just to show you that how the things works. Okay, so I hope these things are clear. So this is really important, that when you apply as an integer, so any word, term means any word that appears in more than 10 documents will be ignored. Okay, so maybe I is appearing in more than 10 documents, then I can be ignored. Okay, here it was 1, so maybe I was appearing in more than 1 document, right? So it was ignored, or less, because our both threshold was 1 1, it was default parameter. So that's how it works. So now let's see here what we have done. So we have put here min df. So again, how, what min will do? Min will be the lower side, that it will ignore the terms that are strictly lower than this threshold. Okay, so for example, and similarly, if it's float, the parameter depends proportion of documents. Okay, it's the same as this proportion of documents, that if it occurs in 85%, more than 85, it will be ignored. Okay, most frequent. So similarly, if it's little less frequent, okay, that is document as strictly lower, okay, so it will be like less than, not less than or equals to. Okay, similarly here it's strictly higher, so it will be greater than, not greater than or equals to. Okay, strictly higher means just greater than, strictly lower means just lower than. Okay, not lower than or equal to, and the given threshold, then it will be ignored. So here we are putting it as 10. Okay, so if the word appears less than 10% of the times in the document, it will be ignored totally. Okay, so that's it for this video, I guess. Rest of the things are the same. We are just doing fit transform, and you can see we have restricted ourselves to 5,000 features max. So we'll just get until 5,000. Okay, number of unique. So here we are doing both, mind it. Here we have both unigram and bigram. Here I just showed you the bigram. Okay, so here it will be both unigram and bigram. Okay, so in next lecture, before moving to TF-IDF, we will train naive Bayes, so that at least we know that what we get as an accuracy after we train naive Bayes, because now we are ready to train, because we have our X, that is our input, the reviews converted into vectors already. So now we can easily use naive Bayes. That is, naive Bayes is also just counting the probabilities, and probabilities are also just counting the ratios, like how many times the event is favorable divided by total outcome. So At the end, we are also counting as well in naive base. So naive base is really, that's why it's really simple, just counting. Okay, that is how many times something occurs divided by total. Okay, so that's it. I hope this video was useful. Thanks a lot.